Hi, I'm Rachana Vishwanathala. In my present role as a developer advocate as a member of IBM Developer Ecosystem Group, my technology focus is on artificial intelligence and my mission is to enable developers on various technologies. I also work with startup communities and have delivered immersive and engaging meetups on a diverse set of technologies, including AI and cognitive services. Security is something that I've drawn towards too. I've always been drawn to the possibilities it brings in. So this is the agenda that we'll be looking at today. So what we're trying to understand is that clients are moving to a cloud-hosted environment. You need cloud because of economic and business values. As you see, a lot of capabilities that are available on public cloud, but people are not ready to put their resources out there. Uh, People say that they will keep our people say that they'll keep their development and test workloads on public cloud while the production remains to be on private. As we are looking at how things have panned out, multi-cloud is the new normal. You have a hybrid multi-cloud situation. What is stopping the customer, what is stopping the developers to adapt this anyways is no marks for guessing, it's security. Security in terms of security breaches in that environment. It is not the cloud isn't secure, but the fact that your attack surface and threat vectors are broad. There has to be a way to address this for cloud users. So this is something that we are trying to understand today. This is the agenda. So the and first and foremost, very common threat that we look in a cloud hosted environment is data breach. In an on-premise environment, IT security professionals have control over the physical hardware and network infrastructure. But in a cloud-based environments, these controls are transferred to cloud or third-party vendor, which makes the environment very much prone to attacks. Hackers can exploit the vulnerabilities in cloud and steal the confidential data from organizations. So, what is the solution here? The solution is to invest in data encryption, tokenization, and threat prevention tools to protect data at rest and in transit. Using intrusion detection and threat intelligence will help us identify and mitigate the threats. Malware injection. It is a kind of attack wherein the attacker attempts to inject an implementation of malicious service or virtual machine into the cloud. So what we're looking at is let's look at the diagram in the window. A user is trying to visit a legitimate website, but what happens is the user is directed to a malicious website, and a malicious website will host a Trojan or a malware. It could be anything. It could be juicing malware or Metapredator payload or something like that. And you inject the malware and get users' personal data and banking details, something like that. So this particular situation is what a malware injection is, and a cloud-hosted environment is very prone to this kind of attacks. And distributed denial of service. So these are the attacks that are designed to flow or flood web servers with too much traffic so the server won't be able to respond to legitimate requests. Cloud computing is based on shared distributed computing and resources and uses different types of virtualization technologies, which makes DDoS security framework a little complex and harder to control. A successful DDoS attack can render a website useless for hours or days. So this can damage the brand reputation, customer trust, and also cause a huge revenue loss to the organization. So what is the solution in such cases? So organizations will have to invest in DDoS protection, um, uh, real-time protection for sophisticated DDoS attacks at every network layer, including 3, 4, and 7, and make sure you configure and manage your domain name system, enable web application firewalls, create global load balancer for additional resiliency, make sure you're creating health check events every now and then too. Insider threats. Insider threats are the employees that threaten the security of organization. Common security failures by employees include poor security are due to poor security awareness, or it could be phishing, it could be social engineering attacks, and a cloud hosted environment is very much prone to malicious insiders because all your workload is not on your server, it is on someone else's server. Or it could be a cloud admin that is a malicious insider. So what is the solution for this particular problem is to educate employees on identity and access management, ensure that the roles are assigned properly with appropriate user personas, encourage safe and smart data access practices within the organization, and make sure you're using better authentication ways like FIDO and SAML for enterprise authentication. Man in the middle attacks. So the problem is that uh, a user and a between a user and a web application, there is someone else in between who is listening to what's happening. So it's like eavesdropping. You in your regular day-to-day life, you come across eavesdropping, right? You're talking to someone, and all of a sudden, your neighbor wants to listen what's happening in your life. So it's something like that, but within a network environment, a user and a web application, and someone else is trying to uh, come in between and steal the data. So how do we address this in a cloud hosted environment? So the only solution that we have is encrypting data at rest and encrypting data in use and encrypting data in transit. So encrypting the data at rest protects information from disclosure, even if it's lost or stolen. Encrypting data in transit through methods like HTTPS, SSL, and TLS prevents eavesdropping and man-in-the-middle attacks. So let's get into the actual security topics on cloud-hosted environments. So the threats part that you've seen are the common threats that are observed in a cloud-hosted environment. So enterprise's perspective on that is that we believe we have an opportunity to get security right. When we are doing cloud security, essentially, if you look at security traditionally, in previous times, it was to create secure zones. So you have an application zone, you have a data zone, you have a DMC zone, and then you put your crown jewel, which is data, at the core behind all these firewalls, or where you have to keep your crown jewels safe and build security around it. So the cycle, if you see, is you create a secure zone, deploy your workload into the secure zone. But when you're doing the same with cloud, we may have to reverse some of this traditional thinking. Traditionally, we're taking an application on a server and we are hardening that and patching that with firewalls. If we have a vulnerability coming up, we are just patching it. So enterprises, especially in a cloud-hosted environment, believe that shift left and do security right. When I say shift left, you're not going to think of security as an afterthought and patch it, but you include your security as a part of development process and extend right in a sense that you do security once it's not done. You have to you have to believe in the notion that security is a continuous process. So again, these are driven by industry segments. We all need business needs for security. We also assume the user experience, speed, functionality is way too better. But for one reason, a lot of people are moving away from using it. It is that he didn't get the security aspects right. There are multiple ways that you can ensure security. In a lot of these cases, you see that it's implemented through a set of acceptable controls. It's all about what is the risk involved and what are the controls that we have to put in place to mitigate the risks. And of course, there is not going to be a 100% secure system. There will always be flaws, but you will know what are the risks. There are a bunch of things that are driven by compliance. Compliance again depends on industry and verticals and all of that. So if you're looking into financial services, PCI apply. And if you're looking at government and public health, HIPAA applies. So similarly, we have FISMA. There are these compliance standards that ensure that we have to ensure our organization is following to ensure that the cloud is secure. Few ways how we ensure security. One of them is security controls, and security controls are defined by standards like ISO, EU, HIPAA, FISMA, and several other controls like SOC 1, SOC 2, etc. Across multiple security subdomains like network protection, identity and access management, workload security, data security, logging audit, posture management, we have multiple security controls and compliance standards. So posture management is a new era that is coming up with which is gaining significance because of multi-cloud. And how do you implement? How do you start the journey and make sure that when you are in journey to cloud, when we are taking the when we are talking to the people who are using cloud, how do we shift left and incorporate security in the process? So it is a highly iterative process where you pick up one set of use case, build that, and move it to cloud. For example, we have been looking into, so this is my experience. Uh, we have been looking into set of capabilities like so entire application is inside a mainframe server, and that is the stuff that they build across 70s. So we are looking at 30 years of legacy and converting all of that into microservices, building all of that code, building the ledger on cloud, and moving the whole solution to cloud. So we're talking about agility, we're talking about squads, we're talking about guilds in terms of iteratively giving them value at the same time and giving the transformation to cloud. So how do we make sure security is injected in each of the squads and in each of these phases? So the one on the screen is end-to-end security solution flow. So we go through this model where we have a current security profile, security assessment, as well as a template which is given to them, which they have to incorporate into their journey. Again, it can be based on assumptions. Imagine we are working on 25 microservices. How do you get same set of capabilities, same set of resiliency, security, reliability, same set of principles built into their squads? This is through guild process and set of principles. So these principles should be socialized and communicated with all the teams. These principles actually give us guidance on architectural decisions, whether it is secure by design, which one should I use? For example, a Node.js application running on a target cloud. So all these methods does not have a target cloud. If a target cloud has these controls, we have to make sure we enable them and use them. So what we have done is break down the architecture, and there are several things that we have to go through to make sure that the aspects are built in. For example, data. How do we make sure the data at rest is secure, data at transit is secure, and data in use is secure? For applications, what is secure engineering practice, secure development? How do I make sure code is safe from vulnerabilities? Each of the green boxes expands to several controls and capabilities we need to have in an overall security architecture. And underlying, you should have the personal and physical security pieces. I think all of this is a big effort, but then lot of it, if you look at, is split between cloud provider and consumer. There are frameworks that you can use from NIST, etc. You identify, protect, and provide, and recover in loop. This is the one slide that talks about end-to-end security. Importantly, there are four things that we need to take care of. Um, if you're starting with secure platform, be it public, private, hybrid, multi-cloud platform, platform security is important. Apart from that, we have three major pillars: identity and access management of application users, developers, cloud admins, etc. Then how do you control authentication to network itself, which comes under network threat protection? The second pillar that we're talking about is about application and data security. Given where we are, data security is taking more precedence. Protection of data always takes precedence. Of course, application security is also important, while we are very keen on data security. We will discuss some of the distinguishing features we have on cloud, and then comes compliance and posture management. Security itself is becoming a big data problem. How fast can you detect an event, and how fast can you detect something critical? How fast can you respond to the event is an important security feature. Going back to my uh, banking example, if it's a new application zone and moving one facility to a cloud, that business owner has to put in certain things in place, like how fast you want to detect a threat, what are the remediation timelines, Is it critical? If it's critical, is it less than 3 minutes? If it's medium, less than 4 hours. If it's low, less than a day. So what these are becoming four important pillars, how we build a secure platform. So this can be this is one of the use cases. How do we understand that clients are ready to put their workloads on public cloud? So Bank of America is one of the largest financial services who has hosted their production workloads on public cloud. So at this point of time, what we're trying to understand is public cloud is secure enough that Bank of America is trusting its workloads with public cloud. So, two security focus areas that we'll be discussing today are end-to-end data protection with exclusive control and how to enable continuous compliance with demonstrable controls. Yeah. Data at rest protection, right? Till date, what is happening was you encrypt the data and you say, my data is encrypted and I'm good. But in a cloud world, encryption is more for amateurs. What matters for the grown-ups is key management because it's like saying that I have logged it but nobody can access because nothing is in clear text. But then, who has got the key? If cloud provider itself has got the key, you're not secure. You're very vulnerable to insider threats. This is a key differentiator that public cloud providers are bringing into the table. So this is one of the significant use cases of key management. It's a service found in it's a service found in most of the cloud catalogs, be it AWS, Google, Amazon, IBM. So, key management is a service that is available on most of the cloud service providers' platforms. But what is important that we support two patterns, BYOK and KYOK. So, this is important because you actually enable the customers to use his own key. So, each customer has their own key, and that is the key which will be used along with the hierarchy of keys to encrypt their data on cloud servers. Even if it's a bad guy, let's say we have a bad operator, or let's say we have a privileged administrator on cloud service provider's side and decides to look up Bank of America's database. He won't be able to get to that because the database file at rest is encrypted by a key owned by customer. So KYOK, know your own key. That particular key can be on HSM or customer location itself. So imagine the key stored on HSM itself is very secure, hardware security module. Nobody can get to the key. Even if someone tries to reverse engineer the key or get the key out of HSM, you will have the key go invalid. So here's a pattern we use. So while within the key management services, you use wrap and unwrap functions. So BYOK and KYOK are the recent trends. How to do that with key management is something that we'll have to figure out. The other part, the beauty of it with key management is it can integrate with cloud object storage or block storage or file storage, or it can be your database services like CloudDent, DB2, MongoDB, Postgres. All of them can pick up a key from key management services and keep your data secure. If you feel that I think someone has compromised my key, all you have to do is you can simply rotate your key and the entire thing becomes secure. But all you have to do, all you will be carrying is a risk of someone secured your key, but which again is the worst case. There is no way that someone can get to your actual key with some of the things in place. Some of these key management operations actually happen in secure zone as well, which is at runtime itself. So now you have a way that not only your data services, but also your Kubernetes services can also pick up the key from key management. That is too powerful. So imagine the capacity that cloud services are bringing in. Let's say your compute is compromised. Your service and data would never be compromised, even if a privileged user gets to it, a malicious insider gets to it. And that we are able to do it because of certain capabilities that are provided by Intel in this context. So Intel TXT component that talks about secure boot of VMs Things like right from the chip level, you're bringing in this trust into the system, or as we are moving to zero trust architecture, where some of these things like we have a solution called secure virtualization for securing VMware workloads, where you have Intel TXT servers and we have high trust and we have key management. So all of that can make sure that, let's say if you want the server to come up only if it's in London, so it will simply verify for geolocation, hence its data control and cloud control, and based on that service is going to come up. So this is one set of the capability. We talked about data at rest protection with encryption. Let's quickly look into data in use protection. So uh, at the hardware infra level, Intel has this set of chips called Intel SGX. So within public cloud, we have a capability where this is one of the scenarios where we have. What it does is, imagine you have your MongoDB is up and running in a container in a Kubernetes service somewhere. If a developer is a smart guy, he can actually go dump that process or kill the process, get the code dump, and try to reverse engineer and look for how does the credit card account look like. And he can actually take away the credit card numbers that are loading into the memory. With such protection, what we can do is even the data that is loaded into the memory of the chip, that can also be encrypted. So this is called data in use protection. This is something very distinguishing feature that most of the public cloud platforms are offering. Imagine it's data that is related to cryptocurrency in the memory. A developer can take away the data, he's a rich man in overnight. That's a risk anybody will be willing to take. So there are customers like blockchain providers and digital assets, etc., who are using this kind of capabilities today. And encrypting the data in transit over the internet through methods like HTTPS, SSL, and TLS prevents eavesdropping and so-called man-in-the-middle attack. Secure Socket Layer (SSL) is a technology that encrypts traffic between the client application and the server application. So this encryption is accomplished by a public key private key system that uses SSL as a certificate. The SSL certificate contains the server's public key, dates for which the certificate is valid, the host name for which the certificate is valid, and a signature from a certificate authority that has issued. So we will have to ensure that we have a certificate managing system as well. For example, you have 80 microservices in one system, and all of these microservices will have to encrypt their data in transit, and hence you have 80 certificates. And it's difficult to manage these certificates. When are they going to expire? Constantly checking on them becomes difficult, and hence you need a managing system that ensures the renewal of the certificates, or if it's going to expire, a simple alert, something like that. And most of the public cloud platform providers are ensuring that they have a certificate management system. Yeah, so that's all about data encryption. The second focus area that we're talking about today is compliance. Overall security monitoring for cloud. So recently, there is something that came up and said security posture management and compliance posture management is important capability to have. So there are these central dashboards that are usually built into cloud platforms where you see all the vulnerabilities and compliance issues with the resources consumed on cloud. This becomes a central piece for security focal to work on. So I know how many containers are vulnerable, how many certificates are going to expire, etc. So certificate management is also a big thing. Each of these microservices will need certificates. If any of the microservice expired, your entire solution can go down. So how to get notified when a certificate expires, how to renew these certificates is something that's managed by certificate management systems on public cloud platforms. So this is a reference architecture that highlights the security posture and compliance posture that public cloud platforms usually follow. It talks about multiple roles like security officer, compliance officer, security engineer, and compliance engineer. And the roles are spread across detection. It starts from detection and remediation. There is workload security, there is container security, there is data security, and then comes network security, which mostly talks about how cloud platforms are isolating your workloads within the server. So to keep up with the competition, what we need is a platform and set of tools that enable getting started quickly and iterating as often as developer services new ideas. Development needs to be executed at the speed of cloud, but with control. So this means reducing the time on assembling tools, deploying and maintaining infrastructure, and analyzing test results, all without lowering the quality. So this means deployments need to be automated with the tool chain. So they can happen up to 20 times a day, but be gated by an automated quality checks, which automatically stop a bad deployment. So we're talking about agile transformation that requires cloud platforms to maximize benefits. DevOps is a way to develop efficiently for cloud platforms. So what we need is both speed and control and quality. So the goal is to deploy 20 times per day with quality. Batching changes is a bad practice. So we need a system where changes are flowing into production quickly for A/B testing and fixing. And we need a system that can take some level of risk when when able to deploy and update urgently within minutes. So this is something DevSecOps, Secure DevOps talks about. So compliance part is again what makes sure that things are in control. How do you get a pat on the back from industry regulation standpoint? You should understand something. You can be secure but not compliant. You can be compliant by ticking off the cheat sheet, etc. But if you have not done your security controls correctly, you may be insecure. So you should treat them separately, but these dashboards are something that brings in this together. OpenSCAP is for containers. So when you're building containers, right, uh, we have to make sure that our container images are scanned for vulnerabilities. So OpenScape is an open source tool that is available, which will scan your container images and give us what are the common vulnerabilities and exposures, and what are the usual configuration issues, and an overall status of image based on vulnerabilities, identified configuration issues, and applied exceptions. So this is another interesting work on cloud platforms, right? So it is to have a way, it is to have a capability for us to integrate our cloud security central dashboards with enterprise security dashboards. While we have security central dashboards for cloud platform, the security CISO also should be able to look at a central dashboard and be able to monitor what's happening on the workloads that are running on cloud. So for example, let's say one application team, security focal, found some bad traffic coming into his cluster. He can create a finding and send it to a CISO, and CISO will have the capabilities which are supported by, he has a feed coming in from all the other parts. So he can analyze and tell, okay, this is coming from so and so IP, and I see similar traffic on few of my other servers, and then evaluate what is the risk, what happened, has there been a compromise. If there is a compromise, a ticket will be raised and taken to a next step to minimize the impact. So this is a valuable integration that public cloud platforms offer. So all your workloads are tested for security, and there will be a central dashboard that will monitor the security status, which can be integrated with your enterprise security dashboards as well. Architecture is designed as an integrated whole across four dimensions. So we have cognitive applications that are trained with more data and expertise than any competitor. And Sophisticated AI services are foundational to cloud architecture, and we allow for customized models. Our competitors only, the cloud providers only offer low level AI, uh, and so your entire architecture has to be built to allow for accelerated AI training. So public cloud platforms typically address most of the compliance standards. Which service in which location is compliant to what set of standards is also important. For example, the one in Frankfurt would adhere to GDPR, etc. And the one in USA may not be the same. It will be some other local compliance standards. In summary, built-in, uh, built-in, and then you can bring in additional capabilities to complement to provide end-to-end security. And these are some practices that will actually help us use good, solid, secure denominator on all clouds, whether we are deploying on public cloud or not. It gives you a hardened RHEL image, which will help you give give you a good base or foundation to your journey to cloud. That's all from my side. So this is cloud security. Thank you.